Hello, welcome back to another episode of Sparky's Tech Corner. Now, we're back at the Onkyo today, and we're going to be doing a little bit of testing. Now, I'm going to have to do some special things to this board so I can get the components I need powered up to test them. What I mean by that is, on this board, we have two relays that controls the main power from these wires to these two capacitors. And what I'm wanting to do is these switches down here, I'm wanting to power them on and then check the voltages going in and then check the voltages going out of each of them, because I got a feeling that our issue is a low voltage situation. The voltage drops down so much that the unit shuts off and then comes back on. This is a theory. I'm just guessing, because whenever I was measuring on the last video on this power supply, I was getting about 41 volts out of here. Well, you look on the diagram, and I'll show pictures as I'm illustrating on here. The power supply going to these transistors here are supposed to be about 53 volts. The power supply to these transistors comes directly from these capacitors, and these capacitors get the supply from this bridge rectifier right here, and the bridge rectifier gets its power, AC power, from these relays which are connected to this transformer. Now, if I'm only getting 41 volts unpowered, then powered on, that voltage is probably going to be lower. So I want to say that the system's not getting enough power to be able to drive the speakers and all the other good stuff. Unfortunately, I can't just hook it up and plug it in, because of all the major components off of it. I've got some circuit protection going into place, keeping me from powering it on. So what I'm going to have to do is I'm going to have to jumper this relay, and this relay. I'm actually going to have to put jumper wires bypassing the switching mechanism, so whenever I plug it in, I can actually power everything and then test everything with my voltmeter. Now, don't do this on your own stuff. I know I'm taking a risk of getting zapped here, but I've got some gloves that are supposed to be electrically insulated, at least I hope they are, that I'm going to be using while I'm messing with this thing while it's plugged in, so I can test all my components. But I'll go back to the schematic view right here. Our circuit board right here, which is this board right here, is our main power input supply. It takes the AC voltage from the wall here and then goes through, sends out lower voltage to the board, and then sends out a higher voltage to the board. This connector right here connects to this transformer right here with this cable. This relay switches on and allows these 2 points to connect to get powered in. Then it sends raw voltage from here to the transformer, which steps down the voltage from 120, and so, like I said, it's supposed to be 53 volts, but I'm only getting 41 volts. And then from there, I've already explained how all this goes, but from the schematic view, it'll come from the transformer at these points on down to this main amplifier board, through the relay, then directly from this relay to this caps. The relay to the bridge rectifier, and then from the bridge rectifier to these two caps. And then from there, it distributes it. So we're just going to go along step by step, measuring each one of these points and see what we come up with. So with that, I'm going to go ahead and speed this up a little bit. I'm going to get some wire, jumper all these points across that I need jumpered, and we'll hook all up and do our tests. Okay, with that being done, let's go ahead and check our connections. I'm going to use dial mode to make sure that everything is hooked up the way it needs to be. I hope you guys can hear that. Okay. Okay, our first one is gonna be from here to there. Okay, our second one from here to here. That's just resistance through the coil. Okay, with that being done, let's go ahead and hook this up and see what happens. Gotta take precautions these days. Okay. Plug in the power outlet. And nothing blew up, and that's a good thing. We don't want it when things blow up. So, first thing I'm going to do is I'm going to turn my voltmeter to AC. Hopefully you guys can see that. And first thing I'm going to do is I'm going to check power going into transformer. Got 115 volts. That's what my wall outlet puts out. So, I know that's good. Okay. Let's see if we can't zoom in a little bit. I'm going to attempt to check the bridge rectifier, but I don't know if I'm going to arc it or not. So, let's see if I can do this. Here. 79.2 volts. Okay, let's check it from up here now. Alright. Whoops. Let's check these 2 points now. $79.3 volts. Let me check from here to here. Okay. Now, let's check our DC side. Let's check with the bridge rectifier. Let's see how it's transforming this power over. Switch my leads to my hands. Zoom out a bit more. Checking from here to here. Got 108 volts going into it. Why do we got 108 volts going into it? We should have... Okay, let's check back at this ground pan. And to here. Okay, that's looking normal. 54.2 volts. Okay, so I had to check the return back to it. Usually when you're converting over from AC to DC, they have different ways of how they do stuff, and it can be monotonous at times. So let's check this one more time from neutral black to, of course, AC side. Let's check here to here. 40.2. 40.3 AC, go over to DC, check to here, 54.4, 54.5.4. Okay, and what I'm going to do is I'm going to check every one of these little transistors. Got 54 volts showing all across the rail, and that's what we want. Okay, all across that rail we're showing good voltage. So, let's see what our outputs have. Ooh. Okay, that's 4 volts. No, it's just showing me millivolts. Okay, let's see. Let's check from this point here to this point here. Okay, again we're showing millivolts. Okay. I'm pretty sure that these transistors are supposed to be putting out a lot more than just that. So, I'm going to bring up a view of one of these transistor schematics. We're going to go off of the 1695. And let's bring that one up. Alright, looking from in here, higher purpose transistor. This one is supposed to reduce it down to about, if I can find it. So, let's try this again. Check from here. Here. 2.8. Alright, plus 15 volts, minus 15 volts. So let's go ahead and check this out. I don't know if I've got this one enabled or not. Okay, everything's being powered the way it's supposed to. Okay, I've got no fuses popping. Everything's working the way it's supposed to, it seems like. Let's undo everything. Let's go ahead and turn the soldering iron back on. Let that get warmed up. And there's one more thing I'm going to do. I'm going to go ahead and check the capacitors on this. These two. They're supposed to be 10,000 microfarad. I want to see what they have on them. And we'll move on to the next step on the whole project after that. Okay, guide fan soldered, the guide fan hot, everything's powered down. Okay, So, from everything what we checked, our power going from the transformer to the amplifier board's okay. The power going from these switches, the capacitor switches, is okay. So let's go ahead and take a look at something. Okay, that's something really interesting. I did not notice this, and this is something that I missed. I'm gonna zoom you in as far down as I can get. See that right there? How much want to bet this is our entire issue right here? It says trace. Let's go ahead and see where that trace goes. I'll put up the PDF here. Okay, let's go back to our board view. And let's find that trace and go from there. Okay, that looks like that's gotta be a ground plane. Okay, yeah, that's gotta be a ground plane. That goes from this connection here to here. So, what we're gonna do is we're just gonna go ahead and remove all this excess. Just break that off. Now what we're gonna do is we're gonna go ahead and solder our little jumpers here. Allow soldering iron to get warmed up. Come on. Come on. There we go. And we're just going to go ahead and solder these. Cool. Now what we're going to do is take a little bit of wire here that we were using beforehand. Strip a little bit off of it. We'll go ahead and solder a little bit here. And we're going to solder a little bit here. I'll try to take that back. We're going to go here instead. Get a nice big old glob of solder on that. And this thing's got to take a bit to heat up. One, we can just Now we got that on there. Let's go ahead and take a piece of wire here. Let's measure it out to here to here. And let's go ahead and cut it. Okay, go ahead. Now, let's strip this other end. If I can get it stripped. Okay. Get a little bit of flux here. A little dab there. Put a little dab there. Okay, I'm gonna go there. Now, let's go ahead. Okay. Do a little bit of a yank test on it. And there we go. We have a proper jumper bar now. So, I told you we were going to test capacitors. This is going to be done in a little bit of a different fashion. My meter won't do the proper measurement on them. So, I gotta do a calculation. So, we'll take our ground, go to here, positive, go to here. Okay, let's go to this one then. Okay, if you can see that, it says 8.53. Which, if you convert that, that's about 8,000 farads. And these are supposed to be 10,000 farad capacitors. So our capacitance in them has dropped down a little bit. So what we're going to do is we're going to go ahead and replace them. So I'm not going to test the other one because the other one's probably the exact same way. So we're just going to go ahead and get some high quality Nishikons and place those bad boys and go from there. But looking at it, I'm going to say our problem might have been with that ground socket. So, with that being said, I'm going to go ahead and call it a day on this one for part 2. Please like and subscribe, and I'll see you guys on the next one.